Hey guys, welcome back. In this little video, we're going to talk about the second and third law of thermodynamics. So the second law. The second law, right? And a definition, right, of the second law is that for a process to be spontaneous in the forward direction, the entropy of the universe must be positive. So for a process to be spontaneous, it means that happens without ongoing outside intervention. And forward, right, as it's written, right? Okay. The change in entropy of the universe must be positive. Well, what do I mean? So here's my universe. There's universe. And that ultimately has some entropy. Well, let's not make it standard state because the universe is not standard. All right. We're going to have a system in here. With some entropy. And we'll have our surroundings. With some entropy. All right. So that means the delta S of the universe would equal delta S of the system plus delta S of the surroundings. Okay. Well, what does this mean? All right. So if we look at delta S, the universe we're not going to touch much with. All right. Now, the system, we already talked about the system, right? And the system, delta S of the system, is equal to the sum of the products minus the sum of the reactants. We're only given the standard values. The surroundings, though. All right. How do we do that? The surroundings are proportional. They're proportional to negative delta H of the system. So that means the surroundings, the SURR, the surroundings, the change in entropy of the surroundings is equal to negative delta H of the system over the temperature. All right. So that's how we calculate the surroundings. All right. So if energy is released in the process, the surroundings gain entropy. And if energy absorbs, the surroundings lose entropy. And that kind of makes sense. Now, the three options for this, for delta S universe, can be positive, it can be negative, and it can be zero. Right, those are your three options. If it's positive, that means that it's spontaneous. That doesn't mean it's fast. All right? It just means it's spontaneous. For example, plutonium has a half-life of, it's in the 10,000 years. It's decomposing in front of people's eyes. It's just not fast. Okay? Just because it's spontaneous doesn't mean it's fast. If it does change in entropy of the universe is negative, we are non-spontaneous. And if we are at 0, it's at equilibrium. All right. And so that's what's going on with the second law. So the second law, this is very, very, much a big picture of it. But the second law basically says that entropy will increase in the universe for a spontaneous process, the overall universe. Okay, because there's sometimes where the system actually decreases in entropy, but it's a spontaneous process, right? Because again, there's more to the story than just this. And so what does this mean? This means that overall, right, all the energy in the universe, right, all the energy in the universe is being spread out across the entire universe. All right, now that's what's happening. And so it's spreading out, becoming less and less usable. And that's pretty much what happens with the second law, is that if it's going to happen on its own, energy is going to spread out. Now, we can compress it, we can compact it, we can make it, make things that have more concentrated forms of energy, right, with higher, stored chemical energy or whatever we're trying to do. But ultimately, what the universe is doing is taking the energy that's concentrated and spreading it out. Right? So that's the second law of thermodynamics. Right? Now, there is something called the third law. And the third law, all right, sorry, my screen jumped there. S equals K, L, and a W. If W equals 1, there's just one way to arrange things. S would be 0. All right? So the third law would be the entropy of a perfect crystal in substance at 0 Kelvin is 0, right? Because there's no motion, there's no randomness, okay? So at 0 Kelvin, which is a theoretical, I guess, a limit, right? It would be 0, right? There'd be no disorder, no randomness. So that would be the third law, right? We're not going to get there, okay? The first law was that the energy of the universe is constant, which is kind of crazy if you think about it. So the first law says all this, basically the mass and energy of this universe is constant, that the energy is going from concentrated to dispersed, and then the third law says if you have a perfect crystal but it has no temperature, there's no entropy. Well, all crystals will have everything has a temperature. Just to look at it, I'm pretty sure it'll have temperature. All right? So those are the laws that we just talked about, the second law and the third law. All right, hopefully that works. If you have any questions, don't hesitate to reach out. We'll see you next time.